All right, now that we've got our unit circle built, let's continue to kind of expand on the different things we can do with it. So we have all the special angles, the 30, 45, and 60s kind of all the way around. Um, and now we want to look at more specifics with each of the quadrants, because if you can do it in one of the quadrants, it's going to be the same in all of them. You just have to adjust your signs accordingly. So we're going to start looking at some properties here, and this is 5.3. So again, make sure you get this stuff nice and organized in your notes here. Okay. So first thing we want to look at is take a basic unit circle and figure out where our functions are positive and where our functions are negative. So we have the 6 main ones. Now there's a big table you can see down here on 392. Again, it's not a memorization piece, but it's just trying to figure out what quadrant we're in, what the x's are, what the y's are, and using our knowledge of those. Okay, so if we have anything in quadrant 1, let's say we put a point right here. Okay, our triangle would obviously look like this. Okay, we don't have to worry about anything in quadrant 1 because both the x and the y values are positive. So quadrant 1, everything's positive. It's always nice. All 6 of them are going to be positive because everything comes from the x and the y. Okay? If we put something in quadrant 2, so we'll just do them with the 45s here because those are nice and neat, and we put our triangle in, okay, this is a positive y, this is a negative x. Okay? So anything with a y value is going to be positive. So that means signs are going to be positive. The reciprocal of a sign, so a cosecant is going to be positive. Okay? Anything with an x is going to be negative because we had to come back this way. So it's got some negative x value. So cosines automatically you think of are negative. Secants are negative. And then remember, tangents and cotangents have these hidden within there. So a tangent is the same thing as a sine over a cosine. So if you make this guy down here negative, well then tangent automatically becomes negative. If tangent's negative, cotangent's negative. So I think about where things are positive because it's easier than thinking about where things are negative because there's always less of them. Okay? If we move to quadrant 3 now, and we put something in here, let's go with 45 again. We draw our triangle in here. Let's get rid of these 2. Okay, again, in quadrant 3, you still have a negative x value. Okay, you had to come back something with an x. So automatically anything in quadrant 3's got a negative x. Well, this y value is negative right here too. So think about what that means. Anything cosine's negative. Anything sine is negative. But when you think about a tangent now, if you get a sine that's negative, you get a cosine that's negative, it actually makes them positive. So quadrant 3 here, your tangents are positive, your cotangents are positive. Okay. Last one we got to go to then is quadrant 4. We put our triangle in. This is a positive x. This is a negative y. So anything with an x, because x is our cosines, is going to be positive. So cosines are positive, secants are positive, and now anything that comes down here with a negative y value, sines, cosecants, automatically negative. Okay, so for this one, we're going to say cosines positive, secants positive. It's easier to think about the positives than the negatives. Now, just like with quadrant 2, if you have the sine be negative, automatically makes the tangent negative. If you have the sine negative, automatically makes the cotangent negative as well. Okay, so there's our 4 quadrants and what's positive in them. So there's only 2 things positive in each quadrant other than quadrant 1. Okay, but it really just comes from knowing your basic coordinate system, putting your points on there, and using what you know about x and y. Okay, so let's look at some examples. Find the exact value of each of the 4 remaining trig functions giving the following sine and cosine values. Okay, so you don't see anything in here about a unit circle. Okay, it doesn't say that, so let's not make any assumptions about our hypotenuse or our radius. Okay, all we know is we got a sine, we got a cosine. If we have those two, we can find all the others. Okay, so they want the other 4. Now, in order to get those other 4, I'm going to figure out which quadrant this guy's got to be in. Okay, so a lot of places sine could be positive, but I think it's easier to think about where cosine could be negative. If the cosine's negative, it's got to come back this way. It's got to have some negative x value. Okay, now we check the sine. Well, sine's positive here because positive y values. Sine's negative here because of negative y values. So this guy's got to be in quadrant 3 like this. Okay, so it's going to come out here to some point right there. Okay, so we already have the first 2. We know what quadrant they're in. That'll help us keep the other 4 values straight here. Okay, so we have the first 2. First one we're going to, or next one we're going to do then is our tangent. We know tangent is a sine over a cosine. We're already given the values, so we can use these. Okay, some of you guys Tuesday struggled a little bit with the dividing fractions. I'd encourage you to write them like this, and then actually go through the long step, how we used to do it by hand, if that helps. Okay, realize if these guys are the same, they'll cancel right out of there. So this turns into square root of 5 over negative 2 square roots of 5.
Jeff Bibby, call 7005. Jeff Bibby, 7005.
Okay, these square roots of 5s cancel right out of there. Okay, you don't have to worry about rationalizing if they're the exact same thing. So this guy turns into negative 1/2. Okay, so we got sine, cosine, we got tangent. All we got to do is get those other 2. Okay, I'm going to go right to cosecant, go to the sine, flip it. Okay, take this guy, rationalize it. Okay, what happened with that now is these 5s can just cancel right out of there. Okay, so the sine originally had to be rationalized because our cosecant is square root of 5. So when you reciprocal it, we had to do that. Okay, so some of these will cancel out and make them a little bit easier. Okay, let's grab the secant now. So all we need for a secant is we need the inverse of the, the reciprocal of the cosine. So negative 2 square roots of 5 over 5. Make sure you keep that negative. Now we're going to have to rationalize this guy as well. Remember, these will give you square root of 25, which is 5, or you can know you're just doing a square root. 10 to square root are the same thing. Okay, you get here. These 5s will cancel right out of there. And negative square root of 5, square root of 5, all over a 2. Okay, so if the cosine was negative, your secant better be negative as well. Okay, only thing that should be positive in that second quadrant are sines and cosecants. Okay, last thing, cotangent. We could go back to the original with all that stuff, but if we know our tangent is just negative 1/2, cotangent's negative 2. So you always have some values that are a little bit harder. You'll have some values that are a little bit easier as well. Okay, let's look at this guy. Find the exact value of the remaining trig functions given the following. So I'm telling you a cosine, so we got one of the six already, and then this. Okay, so it's an inequality here, and it's telling us theta is going to be in between some things. So it's saying theta is greater than 3 pi over 2. So if you need to convert it into degrees, do that. And it's also saying theta is less than 2 pi. Well, 2 pi is 360. So let's throw that guy right there. Okay. Last problem, they gave us the sine and the cosine so we could figure out what quadrant we're in. This problem, they're telling us one value, so it actually could be two places because cosine is positive both here and here, but they have to set the other, the quadrant for us. Okay, so when I see this, I see cosine is 4/5. Automatically, I know I could be quadrant 1, quadrant 4 because of the positive x value. When I see the second piece, 3 pi over 2 up through 2 pi, I know automatically I got to be down here. Okay, so you know your fourth quadrant. So a triangle in the fourth quadrant looks like this. Cosine is adjacent over hypotenuse. So that should be a positive 4 because it's coming out this way here. Radius is never, ever negative. So now we got to figure out what this guy over here is. Do Pythagorean theorem, or you can know your triples, but make sure you set it as -3. Pythagorean theorem will tell you 3. You got to get it so that it is negative because you are coming down. Okay. Once you got your triangle, you can grab all 6 of these. Okay. We got cosine. So do a sine next. Go to your triangle. Sine is an opposite over hypotenuse. Done. Do a tangent. Tangent is an opposite over adjacent. Okay. Do a cosecant. And cosecant, we just flip the sign, or you could go back to your triangle. I think it's easier to flip your originals. And a cotangent. Flip your tangent. Okay. Oh, we did almost forget the secant. Okay. So all we got to do, flip our cosine 5/4. So make sure you got all 6. Make sure they're nice and neat, somewhere all simplified. Okay. Last thing is this guy. Find the exact value. So we say exact. We don't want any decimals when we're doing these things. Okay. Everything's all rationalized square roots. The remaining trig functions given the following. Now this guy's a little bit tougher. It's telling us the cosecant is -3. So the first thing I'm doing is I'm grabbing the sine. -1/3. So I got 2 of those guys right there already. Okay. For whatever reason, and maybe for you guys as well, it's much easier for me to work with sines, cosines, tangents than the reciprocal identities. Okay. So if I can grab the sine as -1/3, I think about the places that the sine could be negative. So anywhere with a negative y value. So here or here. I could be in either of these two quadrants, negative y's. Okay. Now, this guy's telling me the cotangent is negative. Okay, cotangent's less than 0. So I got to think somewhere where my cotangent is less than 0. My cotangent is negative. Okay. Here's a negative x, here's a negative y, positive x, negative y, okay? If you put these guys over each other, because we know a cotangent is a cosine over a sine, so cosine is our x's, so negative x, negative y, that guy comes out positive. So it can't be in quadrant 3. So cotangent's negative, quadrant 4 because of that guy. The double negative will make them positive. So I know exactly where I am now. Okay, so I'm going to make a bigger picture of a triangle in that quadrant. Okay, it's much easier for me to put the sine in than it is to put the cosecant in. Okay, so we know a sine is opposite of -1, because that's the piece that's going to be negative, hypotenuse of 3. It's a good time to check if your numbers all match up. There's no way this guy can be smaller than this guy. So if you end up with something like that, you don't have the right correct numbers. Because right triangles, obviously your hypotenuse has to be the biggest. Okay. So we know sine was -1/3. We get to here. We're missing one thing though. So we got to come find this x value. So we're going to say 3 squared equals -1 squared. We'll just call it x squared. You can call it a squared, b squared, whatever you need to with this. Okay, again, why did you spend all that time in Algebra 2, college algebra, simplifying things like that so we can get to here? Okay, because remember, we're trying to square root 8, so square root of 4 is square root of 2. So now we can go plug in our square root of 2 here. Once you get the triangle, it's easy to get numbers. I'm sorry, it's easy to get values. So grab a cosine now. Cosine is a positive 2 square root of 2. Okay, if you were in a different quadrant trying to find an x value, check if it's positive or negative, because Pythagorean theorem will always give you a positive. Okay, but because of the way we drew it, x's are positive. Okay, so cosine adjacent over hypotenuse, 2 square root of 2/3. Done. Right? So now I'm going to grab my secant. So these are a little out of order because the way we started. So we did cosecant sine, we'll do cosine secant, as long as you get all 6. Okay, so we flip this guy. So 3/2 square root of 2. This is a rationalizing. So 3 square root 2 all over 2 times square root of 4, which comes out as 4. Okay, 2 times 2 gets us to 4. So there's our secant. Okay, so we got 4 of them. Now we need the tangents. So tangent, I could put sine over cosine. So I could take this guy over this guy, but I'm going to go to the triangle. Okay, it just works better for me. So go to your triangle. Tangent is an opposite of -1 over an adjacent of 2 square roots of 2. Rationalize. So negative square root of 2. These guys will come together and give us square root of 4 again. Okay, so 2 times 2 gets us to 4. So we're done with our tangent there. Once you got the tangent, all you got to do is flip it to get the cotangent. So now I'm actually going to go back to my original one here. So I could take this guy here, but I'd have to rationalize it. So I'm going to go back to this little original one and just flip that guy. So cotangents, -2 square root of 2. Okay, focus on being able to get triangles in the right quadrants and not memorizing what's positive, what's negative, but just being able to draw a little picture, think about x's, think about y's. Okay, so come to class tomorrow with some questions on that.